Hi, welcome to lesson 8.3, proving triangles by using proving triangle similarity by side, 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 and side angle side. So as you can see here, we have a table with a lot of different numbers that we really don't need. So we're going to go ahead and cross off these columns right here that we do not need because I think we can accomplish this by only using one of the columns. So what you have here is two triangles that have ABC and DEF as their vertices, and these are their corresponding measurements. So what I have here is using geometry software, I recreated these shapes, 5, 8, 10, 10, 16, and 20, which is what we have right here. Now, one of the things that you're going to notice is that I also was able to recreate what those angle measurements are going to be. Now, I know this is a little bit small, so I'm going to go ahead and zoom in a little bit. And you have angle A, which is 52.4 degrees. Angle B, which is 97.9 degrees. And angle C, which is 29.7 degrees. And on the other side, let me flip it over on this side. You have angle D, which is also 52.4. Angle E is 97.9, and angle F is 29.7. And as you can see, based on the previous lesson, if you have at least two pairs of angles that are congruent, by angle-angle similarity, these are going to be similar. But all it took is just three pairs of sides to be proportional. So how do we do that? Well, let's look at this. Okay, we have DE. Actually, probably this is a little better. We have DE, which corresponds to AB. So DE corresponds to AB. You can see that 10 divided by 5 is going to be 2. 16 divided by 8, that is also 2. Oh, can't see that. And 20 divided by 10 is also going to be 2. So if I can get the three corresponding sides to be proportional, then these triangles are going to be similar by what we call side-side-side similarity theorem. So over here, we can say that ABC, triangle ABC, is similar to triangle DEF by the side-side-side similarity theorem. This is why it was very important for us in Chapter 5 for us to write the congruence theorem, because there is a similarity theorem. So all we need to look for is three pairs of corresponding sides that are going to have the same scale factor, and then the triangles are going to be similar. Let's look at exploration 2 now. Now, on exploration 2, you will need a blank piece of paper. So go ahead and pause the video, put a piece of paper right on it so that we can use it for notes. Once you're done, go ahead and continue with the video. So what we have here, and I'm going to put up the picture, so pause the video and copy it on your paper. Okay, so copy this in your paper. Okay, what you have here is a set of triangles that have two pairs of corresponding sides and an include angle that are congruent. Okay, so you have angle A and angle D that are both 71 degrees. And you have AC and DF that are proportional. Why? Because of the scale factor of 2. So double this, you get this. Double this, you get this. Now the question is, are these two triangles going to be similar? So in order to do that, we need to look for, well, what exactly is going to be the length of BC and EF? If I can show that these two are proportional, then and equal to 2, then these triangles are going to be similar. Or if I can get at least one more pair of angles congruent, then by angle-angle similarity, these will be similar. So using the same triangle, okay, don't redraw these triangles, here are their corresponding measurements. Okay, so off the bat, you can see that, well, you already have those two pairs of angles congruent, therefore by angle-angle similarity, they're congruent, means similar. Or these two. Okay. Now, the other way that we can check is 6.2 divided by 3.1 is indeed going to give you 2. So all three sides are going to be proportional. So we can say that triangle ABC is similar to triangle DF by the not the angle similar theorem, sorry. The side angle side similarity theorem. Okay, now the side angle side similarity theorem requires two pairs of corresponding sides to be proportional, meaning that when you do your scale factor, it's going to be the same, and an included angle that is going to be congruent. Okay, so I would have to divide this by this by this, make sure that they're the same, and I have to make sure that these two angles here are the same. And that is how you apply the side angle side similarity theorem. All right, on the next page, page 233, you're going to do example number 1 right there. At the bottom, you're going to do example number 2 right here. Okay, once again, the side similarity theorem states that if the corresponding side lengths of two triangles are proportional, here's that word that's going to come up quite a lot, proportional. Proportional just means that when you set up your ratios, they all come out the same. So what ratios are we talking about? We're talking about AB to RS, BC to ST, and CA to TR. Now, do you need to set up all three? Technically, no. You can just do it with 2. Actually, yes, on this one, you do have to do 3 because of the side similarity there. Okay? And on the next page, we're going to do example number 3 right there. Which brings us to the side angle side similarity theorem. Okay, angle X and angle M. Okay, those are congruent. So if ZX divided by PM is equal to XY divided by MN, if these two are equal, I set up the ratio of the pair of corresponding sides. If those two sides reduce to give you the same thing, that means they are proportional. And being the fact that you have an included angle congruent will mean that the triangles are going to be similar by the side angle side similarity theorem. Let's go ahead and begin our examples. Okay, here's example number 1. Is either DF or GHJ similar to ABC? So this right here is going to be my pre-image. And we want to know which one of these two is going to be similar to this one. Now what we're going to do, since we do have the measurements, we're going to look at the largest to the largest, the smallest to the smallest, and the middle one to the middle one. So let's do this one first. The largest side on this one happens to be 12. The largest side on this one happens to be 16. So let me set up the ratio of 12 to 16. Let me set up the smallest one, 6 to 8. And then the only thing I have left is 9 to 12. Now, if all of these reduce to the same thing, then by the side similarity theorem, these are going to be similar. So 12 and 14 are both divisible by 4. That's going to give me 3 over 4. 6 and 8 are both divisible by 2, which is going to give me 3 over 4. This is divisible by 3, so that's going to give me 3 over 4. And as you can tell, all three of these are the same scale factor, which means that this triangle is going to be similar to this triangle. Let's do the same process on this one. Okay, 16 here, which is the largest one, corresponds to the largest one there. The smallest one corresponds to the smallest one right there. And the middle one corresponds to the middle one right there. Automatically, you're already looking at this and like, no, this ain't it. Because that equals 1, and you reduce this by 2, and you get 5 over 6. Okay, so even though these two are equal, this one here is not equal. It's a little x. Why complicate things? Okay, not equal. So therefore, this one here is not similar to this one. But this one is similar to this one. Okay, so that is example number 1. Pause it if you need to continue copying that. Now let's make an application now. Let's find out what x is going to be. Okay, so there's many different ratios that I can use here. Now I want to make sure that I use a ratio where at least both of the numbers are provided. For example, AB corresponds to DE. So I can use this one to this one. Now to solve for x, I got 2 choices. I could either use these 2 or these 2. To me, this looks a little bit less complicated than this one, because this one you got distributed property. I mean, it's not difficult, but it's probably your best option. Okay, so because DEF is your image, okay, because remember the first one is your pre-image, and this one here is your image, you want to set up your ratio from the image to the pre-image. So that's going to mean that you're going to have 12 over 4. And that scale factor should be the same as a scale factor of 18 to x minus 1. Now, when you're setting up your ratio, you have to be extremely careful. Because when you're setting this up, you got to go in the same direction. So this one goes to this one as this one goes to this one right here. Same direction. A lot of people do this. They go from here to here, from here to there. Don't do that. Okay, if you go from right to left, you got to go right to left. So now we have to solve this. Now, could I reduce this to make it easier? Yeah, I can do that. I can actually reduce that. 12 and 4, that is actually going to reduce to give me 3 over 1. I'm still keeping it a fraction, okay, because I still need to cross multiply. So cross multiply, that is going to give me 18 times 1. 3 times x minus 1, be really careful. Make sure you actually distribute. Minus 3. Add 3. Add 3, that gives me 21 equal to 3x divided by 3. And x is equal to 7. So they're only asking me for the value of x, so x equals 7. That's example number 2. All right, let's look at the third example. It says you are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so that it's similar to the left and using angle measurements as length shown? So in other words, they're asking me, are these similar or not? Okay, so remember, all I'm looking at here is that I don't have this length here or this length here. So automatically I'm thinking, I wonder if I can apply the side angle side similarity theorem. So let me check to see what I need. For the side angle side similarity theorem, I need an included congruent angle, okay, of which you can see we actually do have that. Do I have proportional sides? Well, let's look at that. Okay, so I have 9 that corresponds to 6. So 9 to 6. 15 to 10. If I reduce these by 3, that's going to give me 3 over 2. That reduces by 5. That's going to give me 3 over 2. So yes, indeed, I do have a pair of corresponding sides, 2 pairs of corresponding sides, and an included angle that is congruent. So yes, you can actually state that triangle GFH is similar to triangle BAC by the side angle side similarity theorem. Thank you for watching, and make sure you guys complete your extra practices and your homework. Have a great day.